This is for Year 12 Specialist. It is the TSSM Exam 2, Question 2. I've done A, B and C in a previous video. This is D and E. So we have our 5 complex roots of 32. And we're told that find the Cartesian equation of the line defined by this. Remembering this is a circle centred at the complex number Z2. And this is a circle centred at the complex number Z3, and we're finding where circles that we draw at both of those points are equal to each other, and the line that determines that. So what might that look like? What I've got is, I've got Z2 there and I've got Z3 there. If I draw a circle on this one and the same size circle on this one, then that's going to have an intersection point which is exactly there. If I was to choose a slightly bigger circle around this one and the same size circle around this second one, then they're going to intersect here and here, and I'm going to get a straight line that looks like that, which is going to be equal distant for all the circles that I could draw from both of them. So I'm thinking that the line that I'm looking for will go down here because it will be equal distant between both of those straight lines. So I've got Z, which is x plus yi minus 2 choose 2 pi on 5. Remembering that's going to be the square root of the real component squared plus the imaginary component squared of each. The real component squared plus the imaginary component squared. And if I square both sides, then I've really got this. So if I could get the real and the imaginary of both of these. Okay, so I've got my situation over here. I'm actually going to go out of fixed mode and I'm going to give you a bigger size screen for you to see so that we know what's going on. So if I just press Exe, that gives me that. And if I go application, so I want to go to interactive. Where do I find interactive? Oh, there it is. Sorry, interactive, complex expand. I'll put answer there, and OK. It turned it into the real component and the imaginary component for me by doing a complex expand. So I might set up here. Okay, so I've set up my structure of what I want, but I might just copy that and delete it and take this and find what, if that was 4 would be. And if I take the answer and I do interactive complex C expand, and now if I edit paste, I can take the x component of this squared plus the y component of that squared should equal the x component of the other one squared plus the y component of the other one squared, which will give me that expression. If I do answer solve for y, there's my equation, and when I drag and drop that, that's the line I'm looking for. So I can write that down as being the equation of the line that I'm looking for here. How many different straight lines satisfy this where ZA and ZB are any two distinct solutions from up here? Well, you'll notice that with this particular one, it goes through Z5. So that's 1. If I pick between this one and this one, that's 2. Between this one and this one, 3. Between these two, 4. Between these two, 5. If I go between this one, there is not one there. If I go between this one and if I jump one, I end up dead middle and I pick the same one that as I got before. So 5 is the answer to the number of these lines. And that's D and E.